In this video, I'm going to go through the solutions to Unit 6 test. The first part is a multiple choice which says, what is the formula for the general term of an arithmetic sequence with the first term equal to 2 and the difference to be 8? We know by definition T sub n for arithmetic sequence is a plus n minus 1 times d. A is 2, so it's 2 plus n minus 1 times d, which is 8. So the answer is going to be D. The next question says, what are the first three terms of a geometric sequence with the first term a to be 2 and the ratio to be r? By definition, T sub n is a r exponent n minus 1. So T1 is 2, T2 is 2 times the ratio, which is 3, so it's 6. T3 is 2 times the first term times r, which is 3 exponent 3 minus 1, which is 2. So it's going to be 2 times 3 exponent 2 is 9, so it's 18. So the answer to this part is B, which is 2, 6, 18. The next question says, which one of the following sums is not geometric or arithmetic? The first one, you have 64, negative 32, 16. So if the first term is 64, if I multiply it by negative 0.5, I get negative 32. Negative 32 times negative 0.5 is 16, and so forth. So this is a geometric sum. The next one, B, 1 to 2, I will add 1 to it. Then 2 plus 1, I get 3. So this is not a arithmetic sum. Now, we have to try the geometric. If I multiply 1 by 2, I get 2. If I multiply 2 by 2, I get 4. If I multiply 4 by 2, I have to get 8. But here is 7, so I'm going to say that this is neither arithmetic nor geometric. The next question says, given the sequence 2, 6, 10, 14, which one of the following is the recursion formula for the sequence? If you look at the sequence, you can see that every term is 4 plus the previous term. 6 is 2 plus 4, 10 is 6 plus 4, and 14 is 10 plus 4. So you can say that the answer is either this one or this one. But since this is a recursion formula, remember that the recursion formula has to stop. Otherwise, it's going to go to infinite loop. And the way to stop it is to have the first term, which is f1, which is the same as a equal to 2. So the answer is D. You may be tempted to say the answer is this one, but this is not a recursion formula because it doesn't have any stopping point. The next question says, which expressions represent the missing terms in the binomial expansion of x minus y exponent 6? The ones that we have to find is this term and this term. To do that one, since we know that the exponent is 6, we have to use the Pascal triangle. So I'm going to expand this one until I get to 7 terms in Pascal triangle. So I'm going to say 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And right now I have only 6 terms here. I have to go one step down, so I'm going to get 1, 6, 15, 20, 15, 6, 1. Now if I expand x minus y exponent 6, I get x exponent 6, negative y exponent 0, then x exponent 5, negative y exponent 1. Remember the sum of the exponents has to end up to be 6. The next one is x exponent 4, negative y exponent 2, and so forth. And the coefficient of these terms are going to come from this row. So this is going to be 1, this one is going to be plus 6, and then plus 15. Now, the one which I'm concerned with is this term, which is equivalent to this term here. Now, negative y exponent 2 is y squared times 15 is 15y squared x4. And if you look at here, this is the 1, 15x exponent 4y squared. So the answer is C. The next question says, list the first 4 terms of each sequence defined below. The first one is Tn is equal to 8 minus 4n. So T1, I substitute n1, so it's going to be 8 minus 4 times 1 is 4, so it's going to be 4. T2 is going to be 8 minus 4 times 2, which is going to be 0. T3 is going to be 8 minus 4 times 3, which is minus 4, and T4 is going to be 8 minus 4 times 4, which is going to be negative 8. The next one, I have to find the first 4 terms if the recursion formula is T1 is equal to 3, Tn is 3, Tn minus 1 plus 5. So I know that T1 is equal to 3, T2 is 3 times T2 minus 1 plus 5, which is 3 times 2 minus 1 is T1 plus 5, but T1 we found is 3, so we get 3 times 3 plus 5, which is going to be 14. The next one, T3, is going to be 3 minus 1 is 2 plus 5, which is 3 times T2 we found is 14 plus 5, which is going to give us 47. And the last one, T4, is 3 times T4 minus 1 is 3 plus 5, which is going to be 3 times 47 plus 5, which is 146. The next question says, write an explicit formula for the sequence 6, 10, 14, 18. First, we have to check to see what type of sequence is it, since every term is 4 plus the previous term, because 10 is 6 plus 4, 14 is 10 plus 4, 18 is 14 plus 4. So this is an arithmetic sequence with the first term a is 6, and the common difference d is 10 minus 6, which is 4. So I can write that Tn is a plus n minus 1 times d. A is 6 plus 4 times n minus 1. The next one says, use the formula to find T20. So I'm going to say T20 is 6 plus 4 times 20 minus 1, which is 6 plus 4 times 19, which is going to be 82. The next question says, find the sum of the first 50 terms for the series 1 over 2 plus 3 over 2 plus 5 over 2 and so forth. First, we have to find the type of series. Since 3 over 2 is 1 over 2 plus 2 over 2, and 5 over 2 is 3 over 2 plus 2 over 2, this means that this is an arithmetic series with a is 1 over 2 and d is 2 over 2, which is 1. So I'm going to use the formula which says Sn is n times t1 plus tn over 2. That's one of the formulas that we talked about in the class, so I can write this one as n times t1 plus tn divided by 2. But we know that n is 50, so first I have to find t50. t50 by definition is a plus 50 minus 1 times d. But we know that a is equal to 1 over 2 plus 50 minus 1 is 49 times d, which is 1. So this is 49 plus 1 over 2, which is going to be 99 over 2. Knowing that T50 is 99 over 2, I can write the formula here that S50 is 50 times T1 is 1 over 2 plus 99 over 2, because T50 we found is 99 over 2 divided by 2. 99 over 2 plus 1 over 2 is 100 over 2, which is 50. So I get 50 times 50 divided by 2, which is going to be 1250. The next question says, determine the number of terms in the following series. First, as usual, we have to find the type of series. I know that 10 is 5 times 2, 20 is 10 times 2. So we know that this is a geometric series with a is equal to 5, r is equal to 2. So I'm going to use the formula for geometric sequence, that Tn is ar exponent n minus 1. I know the last term is 2560, so I'm going to write 2560 is a is 5, so 5 times r is 2 exponent n minus 1. Now I'm going to divide both sides by 5. I'm going to get 2 exponent n minus 1 is going to be equal to 512. If you divide 2560 divided by 5 is 512. Then I take the log of both sides, so I get n minus 1 log 2 is log 512. I divide both sides by log 2. I get n minus 1 log 512 divided by log 2 is going to give us 9. If I move negative 1 to the right, I get n is 10. This means that this series is going to have 10 terms. The next part of the question says, find the sum of the series in part A. In this series, I know that A is 5, R is equal to 3, R is equal to 2, and N is equal to 10. And the series is a geometric series, so I can use the formula which says that Sn is equal to A times r exponent n minus 1 divided by r minus 1. So from here I get S10, n is 10, is the first term, which is 5 times r is 2 exponent 10 minus 1 divided by r 2 minus 1. If you simplify this one, then you get the answer is 5115. The next question says, write an explicit formula for the following recursion formula. We know that T1 is negative 2 and Tn is Tn minus 1 minus 3. So I know that T1 is negative 2. T2 is going to be T2 minus 1 is 1 minus 3. I'm using this formula now. When n is 2 is equal to T2 minus 1, which is 1 minus 3, but T1 by definition is negative 2 from here, so I get negative 2 minus 3 is negative 5. If I find T3, I'm going to write T3 again using this formula is T2 minus 3. T2 is negative 5, so negative 5 minus 3 is negative 8. If you look at this sequence, the first term is negative 2, the second term is negative 5, and then negative 8. This means that every term is the previous term minus 3. So we know that we are dealing with an arithmetic sequence with A is negative 2 and D is negative 3. So we can say that T sub n by the definition is a plus n minus 1 times d. So we say that Tn is a is negative 2 plus n minus 1 times negative 3. The next question says the third term of an arithmetic sequence is 14, so T3 is 14, and the 20th term, T20, is equal to negative 37. Find the first term and the common difference. We know that this is an arithmetic sequence, so Tn is a plus n minus 1 times d. T3 is 14, so we say that 14 is a plus, since n is 3, so 3 minus 1 times d. From here I get a plus 2d is 14. This is my first equation. The second one, T20, is negative 37. So negative 37 is a plus 20 minus 1 times d. So from here I get a plus 19d is equal to negative 37. Now I have two equations in two unknowns. So I'm going to use either elimination or substitution to solve it. So what I'm going to do is that I'm going to subtract this equation from this equation. So I'm going to say a minus a is 0, 19d minus 2d is 17d, negative 37 minus 14 is going to give me negative 51. I divide by 17, and here I get d is negative 3. Now I'm going to put it back. Let's say in this equation I get a plus 2d. So plus 2 times negative 3 is equal to 14. So we say that a minus 6 is 14. So from here a is 20. The next part of the question says state the explicit formula for the sequence in simplified form and use it to find T30. Since this is an arithmetic sequence, I know that the explicit formula for the sequence is Tn is a plus n minus 1 times d. A is 20 plus n minus 1 times d is negative 3. If I simplify this one, I get 20. Multiply negative 3 inside the bracket, I get negative 3n plus 3. Negative 3 times negative 1 is plus 3. So if I simplify this one, I get 20 plus 3 is 23 minus 3n. Now we are supposed to find T30, so I'm going to say T30 is 23 minus 3 times 30. This is 23 minus 3 times 30 is 90. If you simplify this one, you get negative 67. The next question says, a person earns $5,000 in his first 3 months, and then he receives an increase of $300 for every 3 months. So this means that the first 3 months he gets $5,000, the next one $5,300, the next one $5,600, and so forth. But we know at the end he gets $8,500. This is given here. The question is that how long will this take to start from 5,000 and get to 8,500? You can see that this is an arithmetic sequence because every term is the previous term plus 300. So we know that A is 5,000 and D is 300. And I know the last term is 8,500. The formula for general term of an arithmetic sequence is Tn is a plus n minus 1 times d. Tn here is 8,500, a is 5,000, plus n minus 1 times d, d is 300. Now let's simplify this one. I can move 5,000 to the left. I get 8,500 minus 5,000 is 3,500 is equal to then I can write 300 times n minus 1. Divide both sides by 300. You get that n minus 1 is approximately 11.67. Move negative 1 to the right, I get n is 12.67. But 12.67 is not 12.67 month. It's 12.67 3-month. So if I want to state my answer in month, I have to multiply 12.67 by 3. And this one is going to give me 38 months. So this means that after 38 months, the initial earning of 5,000 becomes 8,500. The next question says, in a lottery, the first prize is 100,000, and every succeeding winning number is going to be paid 40% as much as the winning number. So this means that the next one is going to get 100,000. The next one the second prize is 100,000 times 0.4, because 40% in decimal is 0.4, and the one after it is 100,000 times 0.4 exponent 2, and so forth. You can see, obviously, this is a geometric sequence because every term is the previous term times 0.4. Now the question says how much is paid out in prizes if 6 numbers are drawn. So I have to find the sum of the first 6 terms here. We know by definition that the sum of the n terms of an of a geometric sequence is Sn is equal to a times r exponent n minus 1 divided by r minus 1. So S6 is 100,000 because the first term is 100,000. R is 0.4. Exponent n is 6 terms minus 1 divided by 0.4 minus 1. If you simplify this one, you get $165,984. The next question says, using Pascal's triangle, we have to expand b minus 3 exponent 5. So this means I have to expand Pascal's triangle until I get to a row with 6 terms, because 5 plus 1 is 6. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Still we have 5 terms. I need 6 terms, so I'm going to go with the next one, which is 1, 5, 10, 10, 5, 1. Now I'm going to expand this one, so it's going to be b exponent 5, negative 3 exponent 0, b exponent 4, negative 3 exponent 1, b exponent 3, negative 3 exponent 2, b exponent 2, negative 3 exponent 3, b exponent 1, negative 3 exponent 4, and b exponent 0, negative 3 exponent 5. Now the coefficient of each term are from this row in Pascal's triangle. So it's going to be 1 plus 5 plus 10 plus 10, because this is 10 here, plus 5 and plus 1. Now I'm going to simplify it. Negative 3 exponent 0 is 1 times 1 is 1, so I'm going to get b exponent 5. Negative 3 exponent 1 is negative, I'm doing this one. Negative 3 exponent 1 is negative 3 times 5 is negative 15, b exponent 4. Now this one, negative 3 exponent 2 is 9, not negative. Negative 3 exponent 2 is 9 times 10 is 90, so I'm going to get 90b cubed. Now this one, negative 3 exponent 3 is 27, but negative 27 times 10 is negative 270b squared. Negative Now I'm going to do this one. Negative 3 exponent 4 is a positive number times 5 is going to give me 405. B exponent 1. And negative 3 exponent 5 is negative 243 times 1 is negative 243. So that's the expansion of b minus 3 exponent 5. Now the first tips question. The first one says find two positive integers between 5 and 135 so that the four numbers form a geometric sequence. So our sequence is 5. Let's say the next one is x, the next one is y, and then 135. We know that a is 5. We know that T4 is 135. We know that also this is geometric sequence. So Tn by definition is a r exponent n minus 1. Now T4 is 135 is a, which is 5 times r. We don't know what r is. Exponent n minus 1. Since this is the fourth term, so it's 4 minus 1 is 3. Now I'm going to divide both sides by 5. So I get r cubed is 27. Now, taking the root 3 of both sides, I get that r is equal to 3. Since I know what is r, I can find the next two numbers. So I can say 5, the first one, and then 3 times 5 is 15, then 15 times 3 is 45, and then 45 times 3 is 135. The next tips question says, how many direct ancestors, parents, grandparents, etc. would you have had in the last 10 generations? In the previous generation, I'm going to have two parents, one mom and one dad. Every one of them, they are going to have a mom and dad, so it's going to be 4. The next one is going to be 8, and so forth. Now, since I want to know how many in total I have to find the sum 2 plus 4 plus 8 plus, and this is 10 generations. Now, if you look at this sum, you can see that every term is the previous term times 2, 4 is 2 times 2, 8 is 4 times 2. So this means that this is a geometric sum. So I have to find S10, but I know that the formula for Sn is A. A in this case is 2 times R. R here is 2 because 2 times 2 is 4, 4 times 2 is 8, and so forth. So it's 2 exponent n. N is 10 minus 1 divided by R, which is 2 minus 1. This one is 1. If you simplify this one, you get 2046. The next tips question says, find the value of x so that the three given numbers are consecutive terms of an arithmetic sequence. Since this is an arithmetic sequence, I know that a is 2x. That's the first term. Also, by definition, since this is arithmetic sequence, the common difference is the difference between every term with the previous term. So d is 3x plus 1, which is this term, minus 2x, which is the previous term here. This has to be equal with the difference between this term and this term. So it has to be equal to x squared plus 2 minus 3x plus 1. Now, if I simplify this one, I'm going to get 3x minus 2x is x, so x plus 1 is x squared plus 2 minus 3x. I multiply minus 1 inside the bracket minus 1, which is x squared minus 3x plus 1. Now I'm going to move x and plus 1 to the right. I get x squared minus 3x plus 1 minus x minus 1 is equal to 0. So 1 and negative 1, they cancel each other, so I get x squared minus 4x is equal to 0. which is the same as if I factor x out, I get x minus 4 is equal to 0. This means that either x is equal to 0 or x minus 4 has to be 0. From here I get x is equal to 4. So this means for x equal to 0 or x equal to 4, this is true. So let's see what are the terms. If x is 0, then I get 2 times 0 is 0. 3 times 0 plus 1 is 1. 0 squared is 0 plus 2 is 2. So this is one arithmetic sequence, which you can see this is arithmetic because every term is the previous term plus 1. The other possibility is if x is 4. If x is 4, then 2 times 4 is 8. 3 times 4 is 12 plus 1 is 13. And 4 squared is 16 plus 2 is 18. And this is the second arithmetic sequence. The reason is that every term is the previous term plus 5. 13 is 8 plus 5 and 18 is 13 plus 5.